Welcome. Here we're talking section 3.3. We're going to be solving some multi-step equations. We're going to be putting stuff together that we've been doing the last couple of days to solve equations. Woo! Let's do this. Today so I have a process written down here. And we're going to really focus on steps 2 through 6, which, oh my gosh, a 6-step process, Mr. Bishop. We've basically done the vast majority of this. I just wrote in more steps. So you're going to ask yourself what's being done to the variable, also what side it's on, right? So where is it? What side of the equal sign? What's being done to it? How do you undo what's being done to it? Now here's the new thing today. So back in the day when we were simplifying expressions, we went from the top down. When we solve equations or try to undo things, solve/undo, we actually have to undo things from the bottom up. It's like you're being a detective and you're working backwards. We're being a detective to solve for x. And then you just simplify the solution if possible and check your answer like we've been doing. So basically nothing new other than you might find that there's more than one thing being done to x. And when we figure out how to undo those things, we undo addition and subtraction first if there is addition and subtraction. So let's give this a shot. So let's try number 1 here. I don't know if it's I'll just number it number 1, whatever. So x is on the left side of the equal sign. It's being multiplied by 2. I'm just making a little list of what's being done. And we're also adding 4 to it. So these two things I have to undo. I have to undo the addition and subtraction first. So I'm going to subtract 4 to undo adding 4. So we get 2x equals 8. And then to undo multiplying by 2, we divide by 2. So we get x equals 4. I'm going to circle that, but I probably shouldn't. Let's just double check and make sure that's right. So what is 2 times 4? And now as we're simplifying, as we're checking our answer, we do multiplication first and addition second. We follow the order of operations. So 2 times 4 is 8. 8 plus 4 is 12. That's totally correct. Cool. Let's try this over here. What side is x on? It's on the right side. Now, I would recommend adding the opposite here. So it says 2 minus 4 times x. Let's go 2 minus. Let's change that subtraction sign to adding the opposite. So now it says 2 plus negative 4x. It's going to help us answer what's being done to x more correctly, likely. So what's being done to x? Well, x is being multiplied by what? By a negative 4. What else is being done to the x over here? It says x, and then there's the operation plus, x plus 2. We are adding 2 to the x. So we undo adding first. When we're solving or undoing or trying to isolate x, we start down here with our order of operations. So we undo adding 2 by subtracting 2. So we get 8 equals negative 4x. We undo multiplying x by negative 4 by dividing by negative 4. So we get, boom, negative 2 equals x, or x equals negative 2. Let's substitute that back into the original equation to make sure that's correct. So we're saying that 10 is going to equal 2 minus 4 times negative 2. Now really, folks, if you have a calculator, you can just type in 2 minus 4 times negative 2. If it knows the order of operations, most calculators do, some actually don't. You will get 10 here. The answer is 10. Oh no, I have limited battery life. We'll see what happens here. Let's try the last one on this page. So x is being multiplied by 1/3, and then it's also being subtracted by 3. So we'll undo addition and subtraction first. In this case, we'll undo subtracting by 3 by adding 3. So we get 1/3 x equals 12. How do we undo multiplying a variable by a fraction? We multiply by the reciprocal. So we get x equals, well really this is just 12 times 3 because 3 over 1 is the same as 3. So we get 36. Boom. Oops, you know what? I checked that answer before here and I forgot to circle it. I like circling it, but I usually don't do it until I actually check my answer or I feel confident. this case, I feel pretty confident. 1/3 times 36 is 12. 12 minus 3 is 9. That's solid. I'm going to push you a little bit here. So now we're going to see if we can simplify stuff first. So we were just focusing on these questions, but now we're going to go up here. Can we simplify the left or the right side? Well, the right side is just 6. We can't simplify that, but we can simplify the left side. Are there parentheses? Yep. If so, can you distribute? Yeah, let's distribute here. So we get negative 3x plus 6, right? Because negative 3 times negative 2 is positive 6. Add the opposite there if you don't trust that that's a negative 2. So now let's undo adding first by subtracting. What's on this right side? Nothing. Now, when it was nothing over here, we didn't write anything down because we had this to write down. But there's nothing on that right side now, so we write down the number 0 because we need to have something on the left and we need to have something on the right, even if that something is 0, as we solve an equation. Now we divide by negative 3. So we get x equals 0. Let's try that. So what's 0 minus 2? I'm going to go back to the original equation. 0 minus 2 is negative 2. What's negative 2 times negative 3? Positive 6. It's totally correct. All right. Before we start solving, if we can distribute, we should do that. So we get 1/2 x plus 4 equals 16. Cool. So now we'll subtract 4. And then multiply by the reciprocal. So 2/1, which is really just 2, right? Multiply by 2. Taking half of something and doubling something undo each other. So we get 24. Could be so we plug that back in. 24 plus 8. Notice I'm simplifying within the parentheses first. Is 32. Half of 32 is 16. So when you can distribute, distribute. Are there Now, if we look at this next one, it says 3x plus 5x equals 24. Now, I'm supposed to get x by itself. I'm supposed to ask the question what's being done to x. And when there's 2 of them, that's really tough to answer because there's a bunch of stuff being done to a bunch of x's. Before we want to try to do steps 2 through 6 down here in green, we want to simplify this. So, are there parentheses? No. So we don't need to distribute. Are there like terms on the same side of the equation? Yes. If so, combine like terms. I can combine these. 3x plus 5x is 8x. Oh, now I just have 8x equals 24. This is an easy one. What's being done to x? It's on the left. It's being multiplied by 8, so let's divide by 8. We get x equals 3. And when you, I forgot to use a different color on that one. That's a bummer. Now when you plug in that 3 back in, you get 3 times 3 plus 5 times 3 equals 24. You get 9 plus 15. Does that equal 24? Checkmate. All right, last set right here. So what would we do here? This looks complicated. Can you simplify? Can you distribute? Yes. So we get 6x minus 2 equals 16. So now we'll add 2 and add 2, and we get 6x equals 18. What's being done to x? It's being multiplied by 6, so we divide by 6. We get x equals 3. So then, as you plug that in, follow your order of operations now. Should be using parentheses as I substitute in. So we get 9. 3 times 3 is 9. Minus 1 is 8. 8 times 2 is 16. Boom. Next example. Can we distribute? Nope. Are there like terms? Nope. Are there variables on opposite sides of the equation? No. So we can start answering what's being done to x. It's being divided by 2 and subtracted by 5. So we undo addition and subtraction first. X divided by 2 equals 7. So how do we undo dividing by 2? We multiply by 2. X equals 14. Boom. Last one. This is the last one, I'm pretty darn sure. So are there parentheses? Can we distribute? Yep. Now the parentheses end right there, so we're just multiplying that 3 to those two things. So we get 3x plus 6 plus 3x plus 4 equals 70. Are there like terms on the same side of the equation? Yeah. On this left side, there's a lot of stuff going on. There's x's and there's integers, or numbers, or constants. So when we combine the x's, we get 6x. When we combine the constants, we get 10 equals 70. Now this is simplified. Now I can answer what's being done to x and solve. So x is being added by 10, so I'm going to subtract 10 because we undo addition and subtraction first. So we get 6x equals 60. Divide by 6. Whoa, divide by 6. I got excited on that one. X equals 10. Boom, you can plug it in and check it. It works. Holy moly, look at that big equation you just solved. That's exciting.